Welcome back. In previous class we have seen with reference to syllabus what is logic family and what are the different logic families are available and subclassification in each and every logic family like bipolar logic and MOS logic families. In this session I would like to discuss what is the structure of CMOS logic family, how to construct CMOS inverter, its operation, and also the construction of the gates like NAND gate and NOR gate. Coming to the structure of CMOS, it includes two networks. One is PMOS pull-up network and another one is NMOS pull-down network. That means the pull-up network consists PMOS transistors only, whereas the pull-down network consists only NMOS transistors. And in this structure, the inputs are commonly connected to both pull-up and pull-down networks. Output is considered in between pull-up and pull-down networks. Pull-up network is connected to VDD, whereas pull-down network is connected to ground. This is the structure of CMOS inverter. And another important point here is the number of transistors in each network depends on the number of inputs of a gate if the gate gives a complement equation. Generally, the number of transistors in the CMOS structure is equal to 2n transistors. Let us take NOT gate as an example. It is also called an inverter. In NOT gate case, the number of inputs are 1. And its Boolean equation is, suppose if the input is A, its equation is A bar. Therefore, one PMOS transistor and one MOS transistor you need to take to construct CMOS inverter. Let us see how to draw or how to construct CMOS inverter. Let me draw first of all PMOS transistor. So T1 is the PMOS transistor and T2 is NMOS transistor. And here input is commonly connected to both PMOS and NMOS transistors. As per the structure, the output is considered in between PMOS and NMOS transistors. PMOS transistor is connected to VDD and NMOS transistor is connected to ground. So this is the circuit for the CMOS inverter. Now let us observe the functionality of it. Is it satisfies the function of inverter or not? So to understand the function, let us observe what is the state of each transistor with reference to logic 0 and logic 1 inputs. For that, here I represented one table based on the operation of the MOS transistors. Suppose if the input is logic 0, the state of NMOS transistor is off state, whereas the state of NMOS transistor is on state. Similarly, suppose if the input value is logic 1, the state of NMOS transistor is on state, whereas the state of PMOS transistor is off state. If you remember this table, you can understand the working of any CMOS structure. Okay? Then let us observe the functionality of this inverter applying logic 0 and logic 1 separately. First of all, I am going to apply logic 0 as the input. Let us take CMOS inverter. Apply the input is logic 0. With reference to logic 0 input, the state of NMOS transistor is off state and the state of PMOS transistor is on state. Since the state of NMOS transistor is off, it acts as an open circuit. Therefore, the output voltage is open circuited voltage, since the output is across pull-down network. Okay? So the output circuited voltage is maximum voltage, here approximately equal to VDD. That high voltage is considered as logic 1. Let me fill the functional table with reference to this operation. The functional table includes the different columns like inputs, number of transistors and outputs. Now here the input is logic 0. With reference to logic 0, what is the state of T1 transistor? That is on state. Similarly, what is the state of T2? Off state. Okay. Since the state of T2 transistor is off, the output voltage is open circuited voltage, hence the logical value is 1. Okay. So with reference to logic 0 input, here we are getting logic 1 output. So in this case, this circuit satisfying the functionality of the inverter. Similarly, let us observe the functionality of this inverter network with reference to one logic input. Okay. Let us take CMOS network, apply logic 1 as an input. With reference to one input, the state of T1 transistor is, NMOS transistor is on state, whereas the state of PMOS transistor is off state. Therefore, the T1 transistor, that is PMOS, in the open circuited mode, whereas T2 transistor in short circuited mode, since it is in on state. Therefore, the output voltage is short circuited voltage, that is almost 0, that is considered as logic 0. Hence, the functional table is with logic 1 input, the state of T1 is off, whereas the state of T2 is on. So, therefore, the output is logic 0. So, in this case also, it satisfies the function of the inverter. Therefore, this is the circuit for the CMOS inverter. Let us see the characteristic curve of CMOS inverter. It is also called transfer characteristics because it shows the relation between inputs and outputs. Usually the input is represented on x-axis and output is represented on y-axis. With reference to very low input, the output of the inverter is logic high value. Whereas with reference to high input, the output is logic low. Okay. Now let us see the construction of NAND gate. In case of NAND gate, by default the NAND gate has two inputs. So the number of transistors in each network, that is either pull down network or pull up network, are more than 1. If the number of transistors are more than 1, they may be connected either series or shunt connections. Let us see how to construct two transistors in series. So this is the series connected MOS transistors, and the shunt connection representation is like this. Okay, now coming to construction of NAND gate. First of all, you need to write a Boolean equation for each and every gate for which you are going to develop CMOS structure. Okay, so what is the Boolean equation for the NAND gate? AB whole bar. So therefore, it has two inputs. One input is A and another input is B. Hence, two NMOS transistors and two PMOS transistors you need to take. Now, what is the connection between the NMOS transistors and what is the connection between PMOS transistors? And remember here one point is the pull-up network connection is always opposite to the pull-down network connection. Okay. Now, first of all, connect NMOS transistors or pull-down transistors. Here, the relation between A and B is product relation. Therefore, the A NMOS transistor and B NMOS transistors are connected in series. Okay. So, with reference to this connection, the pull-up transistor connection is automatically, that is shunt connection, because I said already pull-up transistors connection is always opposite to the pull-down transistors connection, and inputs are common for both pull-up and pull-down transistors. Output is considered in between pull-up and pull-down. Pull-up circuit is connected to VDD and pull-down network is connected to ground. So this is the construction. Then let us fill the functional table. After that, check out, is it satisfying the truth table of NAND gate or not. The functional table of NAND gate is, already NAND gate